Alright, so the first thing we're going to look at is x less than a, which translates into anything smaller than a, but not including a itself. So anything smaller than a means we're going to go all the way back to negative infinity and stop at a, and then a is going to have a parentheses where we are not going to include it. Now on a number line, you have to think of it as some random a out there that has an open circle on it, and we are shading everything before it. Okay. Now the difference between that and greater than or less than or equal to pretty much is that symbol on a itself. So this time we're going to include it, which means we put a bracket on it. And in our number line, we draw a closed point. And other than that, it's everything before it. Okay. And then we're going to flip directions. So anything greater than or equal to a, which means we start at a, and we're going to include it. We include it because of that little underlined symbol right there. And this time we're going to go all the way up to infinity. So on a number line, we would start at a, close point, and then shade everything bigger than it. Okay. Then we have anything between a and b, where a itself is not included, but b happens to be. So on a number line, that would mean that at a there's an open circle, and at b there's a closed point, and we're shading everything in between. Then we have all real numbers. So we're going to put parentheses around infinity. Anytime you have infinity, you're always going to put parentheses around it. You cannot include infinity. Infinity is a concept, not a actual physical number or location. And then as far as the number line goes, you would literally just shade the entire number line. And then we have a to b, which are both open circles. And then this last one, there's a bracket on A and a bracket on B. And so the only difference here would be A and B themselves would be closed. Okay, and there's other combinations and variations out there, but that's pretty much a good start as far as translating into open and closed and recognizing those sorts of things. Okay, so the next thing we're going to look at are some different types of examples of things you might encounter as far as domain restrictions go. So sometimes it's easier, instead of asking what are possible x values we can use, sometimes it's just easier to look at, well, what can't we use? And so things like fractions, where we know we can't divide by 0, we want to avoid that. So we look at what numbers would make 0 show up in the denominator. Things like square roots, where we want to keep everything positive. We don't want to bring I into it. So those sorts of examples, I'm going to go through at least the first 5 here, just to kind of illustrate some different types of things you might encounter. And I'm just going to refer back to those rules. So for this first one, number 1, you've got a polynomial function. There's no, if you're looking at it, you're going to stop and ask, well, what can't I have? What wouldn't be possible? And for a regular polynomial, there's absolutely no restriction. So that would be all real numbers as far as that goes. Number 2, we have a square root function. And what I want to think about are, where do I get, I want to avoid negatives. Negatives, you're dealing with square root of -1 or square root of negatives, which means i's in there. So I'm going to do what's called a sign test, and I'm going to look at, well, where is 0 at? And inside the square root, if x is -3, then I get square root of 0, which is fine. We can take the square root of 0. But I want to stop and think about, where do I have positive and negative numbers? So I'm going to sign test this, and by sign test, I'm just going to pick numbers on one side of -3 and then on the other, and just look at the overall value of that. So if I put a -4 in, for example, so -4 plus 3 is -1, that gives me negative numbers. But if I stick a -2 in there, if I evaluate it at -2, -2 plus 3 gives me 1, I get a positive. Okay, so now I have enough information, I can stop and think. Where am I guaranteed to have positive numbers? It's things that are bigger than -3, and with square roots we actually can include the -3 since we can't take the square root of 0. So the domain would be -3 up to infinity. Okay, number 3, we're looking at fractions, and in fractions we want to think about what'll put a 0 in that denominator. So one trick is to just solve for x, take the denominator, solve, and I get x is 4. So what that tells me is I just can't have 4 in the denominator. All right, so basically I want to write everything but the number 4. So I do that saying negative infinity up to 4 union 4 to infinity. And then I'm guaranteed, and what that says everything up to 4, and then everything after 4, but 4 itself is just not included. Okay. Number 4, we're dealing with log. Okay, with logs are only defined in terms of positive numbers. So again, I want to, kind of like a square root, I want to do a quick sign test. I'm going to take that inner piece, that x plus 2 equals 0, figure out where 0 is. And so it seems all the interesting things happen around negative 2. So I want to pick numbers, like negative 3, negative 1. And as you get better at this, you're going to find you actually don't need to go in this much detail. But if you're not quite sure, this really does help. And so if I stick a negative, if I evaluate this at a negative 3, I get negative 3 plus 2, which is negative 1. And if I do negative 1 plus 2, I get positive 1. So on this side of 2, the negative 3 side, I get negative numbers, and on the 2 side, or the negative 1 side, I get positive numbers. So I want to say that it's anything bigger than negative 2. Unlike the square root, I actually don't want negative 2 in this. So the negative 2 has a parentheses on it, and that'll guarantee positive numbers. Okay. And then we get something like 5. 5 is sort of this combination where we're combining all sorts of different rules. And it's just a matter of, who does the most controlling in this relationship. Well, let me just start by listing out a couple of facts, and we'll kind of look at where the overlap between all these rules are. I notice I've got a fraction, and in the fraction, I know I cannot have a negative 5 there. So if I have a negative 5 there, that would mean I'm dividing by 0. And then I look at the numerator. The numerator seems to be around 3. If I put a 3 into the numerator, I get 0. So I want a sign test around 3. So we'll go with 2 and then 4. And again, I'm trying to figure out where do I get my positives and negatives. So if I evaluate this at 2, I get a positive number. And if I evaluate it at 4, I get a negative number. Okay. So what this is telling me is I want anything smaller than 3. 3 can be included, but anything past 3, like 3, 4, and 5, they're not going to make the list. They're not going to be part of the domain. So putting these two concepts together, I want anything below 3, but not negative 5. So I'm going to go all the way up from negative infinity up to negative 5. So I'm going to skip negative 5. That's that union thing with the parentheses. And then from negative 5 all the way up to 3. And at 3, I'm going to stop. And so that would be the domain of this particular function.